Welcome, folks. In this video, we're going to review two concepts from last year, simplifying radicals and solving quadratics by completing the square. I'm going to talk rather quickly, so if I'm going too fast, just a reminder that you can always pause me, you can stop me and rewind me, whatever it takes so that you get what you need to understand. All right, so I'm going to jump right into this on page 36 in my green packet. And the directions here give us a bunch of radicals and they tell us to simplify. So first thing I'm going to do is I'm going to look underneath that radical symbol, and if the number underneath the radical symbol is a perfect square, this is going to simplify really easily. Unfortunately, when I type square root of 288 into my calculator, I don't get a nice even round number. So what I'm going to have to do is I'm going to have to simplify, and I'm actually going to simplify by finding some factors of that number that's underneath the radical sign. But I want to start with the number not under the radical sign first. That -8 out in front, he's not part of the radical, so he's just going to cruise on down to the next line. But then what I'm going to do is I'm going to break that 288 apart into factors that are perfect squares, and they're going to go under my green radical sign, factors that are not perfect squares, which will go under the red radical sign. Let's take a minute to review numbers that are perfect squares. If I square 1, I get 1. That's really not any fun, so I'm not even going to include it in my list. But if I square 2, I get 4, making 4 a perfect square. Squaring 3 gives me 9, which is the next perfect square. Then 16, 25, so on and so forth. And I'm just going to make a nice list of these perfect squares across the top of my page. And I think I'll stop when I get to 144. Just a reminder, if I'm going too fast, just pause me or stop me so that you can catch up. And then I'm going to go to my calculator just like I did when we did factoring with polynomials, and I'm going to type in y equals 288 divided by x, because I'm looking for factors of 288. And when I do that, and when I go to that list, I want to find factors from that list that are also perfect squares. Now, a lot of times, a number will have more than one perfect square factor. And if it does, your job, your mission is to find the largest perfect square factor, because that'll make things easier. Instead of having to simplify multiple times to get to your answer, you can do it once and be done. So when I go to look at that list in my calculator, I find that the largest perfect square factor of 288 is 144. And 144 is the perfect square factor. It goes underneath the green radical sign. 2 is the number which I multiply 144 by to get the 288. So again, notice that if I multiply the 144 times the 2, the result I get is the 288. And then now, by design, we can take the square root of 144. Square root of 144 is equivalent to 12. So in my problem, I'm going to replace square root of 144 with 12. Square root of 2 we cannot take, and so it simply remains square root of 2. And so now, when I get out my calculator and I do my -8 times my 12, doing that tells me 96. And it's negative because I'm multiplying a negative times a positive. And the square root of 2 remains the square root of 2 because it's not a perfect square and I cannot take its square root. And if I were to type -96 root 2 into my calculator and type -8 root 288 into my calculator, I should get the same decimal approximation for each. All right, moving onwards to number 2, I'm going to approach this exactly the same way. The 8 is going to cruise on down to the next line. 108, not a perfect square, so I'm going to split that apart into factors that are perfect squares, and they'll go underneath the green radical. Factors that are not perfect squares go under the red. I always put my perfect square factors first because it makes simplifying easier. So again, I'm going to go to my calculator, and in my calculator, I'm going to find the factors of 108 by typing in y equals 180 or 108 divided by x. And when I do that, I'm going to look for the largest perfect square factors because again, a lot of times it'll have more than one. We want the largest perfect square that's a factor of 108. And that is, my calculator tells me 36. 36 will go in there 3 times. And 3 is not a perfect square, so it goes underneath the second radical sign. And now, by design, I can take the square root of that number underneath the green radical. Square root of 36 is equivalent to 6. I cannot take the square root of the number under the red radical, so that remains root 3. And now when I multiply the 8 times the 6, I get 48 square roots of 3. So we've done a lot of this year when we did distance formula, but there's a nice review of simplifying radicals if you need it. At this point, I'm going to go ahead and scoot ahead to page 39. I want you to come right along with me. And on page 39, I'm going to jump down to question number 14. We totally bypassed the directions. The direction said solve by completing the square. We've done some solving now by factoring. Factoring is a great method when your solutions are rational, but factoring can't always be used to solve a quadratic. So in the event that factoring doesn't work, this is simply another strategy that you can try. Just like we have some steps to follow for solving by factoring, we also have some steps to follow when we're solving by completing the square. The very first thing that we're going to do is we're going to move any terms that have the variable in them to the left side of the equation, and any terms that don't have the variable in them to the right side. So in this example, the n squared and the 2n both have n's in it. The minus 13 at the end doesn't, so I'm going to go ahead and begin by adding 13 to both sides. So on the left side, I have my n squared plus my 2n. On the right-hand side, when I combine the negative 3 and the 13, I end up with my 10. And now I'm going to do what's called completing the square. Completing the square is going to be finding some mystery term and adding that mystery term to both sides of the equation. So in other words, I'm going to add that mystery term to the right side. And I'm also going to add that same mystery term to the left side. Now finding this mystery term can be a little tricky, but it's not terribly difficult. You might remember from last year that we find the mystery term by taking half that number that's in front of the n term and squaring it. So half of 2 is 1. And when I square 1, I simply get 1. That is the number that I'm going to add to both sides of my equation. If I were you, I would write this down, take half of 2, square it. That is usually, from my experience, the hardest part of this process for kids. Now what I'm going to do is I'm going to go ahead and I'm going to factor the left side. And the left side will always factor. In this situation, it's going to factor into n plus 1 times n plus 1. And I'm going to combine the terms on the right side at the same time to get 11. By design, the two binomial factors on the left side of the equation will always be equal to one another. So this is really n plus 1, the whole thing squared. And why this is useful is now I can go ahead and I can take the square root of both sides. So when I take the square root of a number that's being squared, well, the square root and the squaring just undo one another, and you're left with what's underneath the radical. So in this case, just the n plus 1. And when I take the square root of that 11 on the right-hand side, I have to remember to take both a positive and a negative square root. If the number underneath that square root was not fully simplified, we would have to simplify the square root. But in this case, 11 is prime, so I know that it doesn't have any factors that I can go ahead and simplify. And the last thing I'm going to do to wrap this up is I'm going to isolate the n by subtracting 1 from both sides. So now on the right side I've got this negative 1 plus or minus the square root of 11. If I like it, I can leave that answer exactly as it is. But I'm going to remind you that you might see this answer written as n equals negative 1 plus the square root of 11, or n equals negative 1 subtract the square root of 11. That's another way of saying or using that plus or minus. These two answers are two different ways of expressing the exact same answer. Beautiful. All right, so that was a nice one to look at to kind of get us started. I'm going to go ahead and backtrack now to page 38, and on page 38, I want to take a look at number 6. This one too, directions are exactly the same, solve by completing the square. So first thing I'm going to do is add or subtract any term that does not have an a in it so that I can move all my a's to the left side and all my constants to the right side. So I'm going to add 68 to both sides, leaving me with a squared subtract 14a equals 71. I'm going to go ahead and complete the square. So it's a squared subtract 14a plus some mystery number equals my 71 plus that same mystery number. To find the mystery number, I'm going to take half of whatever you see in front of the a and square it. So half of 14 is 7. 7 squared is 49. 49 is the number that gets added to both sides. You might say, well, Miss McCann, that number in front of a is a negative 14, so my number is a negative 7. I really don't care about positives and negatives in this case, and that's really unusual because usually we pay very careful and close attention to positives and negatives. But remember that no matter whether the sign of the number is positive or negative, when we square it, it's going to be a positive number, and as a result, it's added to both sides. So this is one of those rare instances where I really don't care too much about the sign, positive or negative, of that number. At this point, I'm going to go ahead and factor. This will factor into a minus 7 times a minus 7. And I'll combine those two terms on the right-hand side to get 120. I can now go ahead and rewrite the left-hand side as a minus 7 squared. And at this point, I'm all set up to go ahead and take the square root of both sides. Remembering that when I take the square root of the right-hand side, I have to take both a positive and a negative square root. Unlike the first example, where the number under the square root was prime, this time that 120 that's living underneath the square root does have a factor that's a perfect square, and it does need to be simplified. So I'm going to go ahead and simplify simplify that radical. That 120 can be factored into 4 times 30. And in this case, 4 is the perfect square factor. 30 is not the perfect square. So that ends up being 2 square roots of 30. I'm going to go ahead and add 7 to both sides. And when I do, I get 7 plus or minus 2 square roots of 30. Let me go back and fill that in. And again, that might be how you might see the answer. You might also see this as written as a equals 7 plus 2 square roots of 30, or a equals 7 subtract 2 square roots of 30. So two different ways to say the exact same idea. Ooh, this is fun. This is some good looking algebra. All right, I'm going to keep talking fast to get one more example in here. So let's go ahead and let's take a look at number 7 that says b squared plus 4b minus 72 equals 5. And even if this process was uncomfortable at first, you should be starting to feel a little bit more confident in this as we move along. Remember, like anything else in life, the more we do, the better we get, and the faster it goes. So let's go ahead. I'm going to add 72 to both sides. This time I'm going to do that mentally. So on the left, I've got b squared plus 4b. On the right, I've got 77. In the next line, I'm going to go ahead and complete the square by adding that mystery number to both sides. And that mystery number, remember, I'm going to find by taking half and then squaring it. So half of 4b is 2. When I square the 2, I get 4. That's the number that adds to both sides. When I factor the left side, I end up with b plus 2 times b plus 2. Combine the terms on the right side, leaves me with 81. So now on the left side, I've got b plus 2, the whole thing squared. Combining, I'm going to just leave that 81 alone on the right side. I'm going to square root both sides. So I end up with b plus 2 equals plus or minus. Oh, and this is cool because square root of 81 is 9. So this is a nice instance when I can fully simplify that square root and the radicals completely take off out of the problem. I'm going to subtract 2 from both sides. So now I end up with negative 2 plus or minus 9. So in other words, I've got negative 2 plus 9, and I've got minus 2 minus 9, which tells me that b can either be 7 or b can be negative 11. So in this case, we've got answers that are rational. Oh, that was fun. All right, let's take a look at one more together. My goal was to get done in kind of under 20 minutes, and I'm not quite there yet. And besides, the more we do together, the less you have to do on your own. So I'm going to go ahead and jump down to number 10. Again, I'm starting to feel a little bit more confident in the process. I'm going to subtract 23 from both sides. My next step is to go ahead and complete the square by adding that mystery number to both sides. And again, I find that mystery number by taking half of that 16 and squaring it. So that ends up being 64 because half of 16 is 8, and when I square 8, that's where I get the 64 from. This will factor into r plus 8 times r plus 8. Combining the terms on the right side gives me 36. So now I've got r plus 8, the whole quantity squared on the left side, equals 36. And I'm set up to take some square roots. So I end up with just plain old r plus 8 on the right, a plus or minus, sorry, r plus 8 on the left, and that plus or minus 6 on the right. Subtracting 8 from both sides leaves me with r equals minus 8 plus or minus 6, which is minus 8 plus 6, or minus 8 subtract 6, telling me that the value of r is either negative 2 or negative 14. All right, so that was nice that we could knock off a few of those together. For those of you who are watching this from in the classroom this morning, you have Mr. Korea there who's an amazing resource and I know would love to help you if you bump into trouble solving any of the remainder of these quadratics. If you're working from home, you can always shoot me an email or ask me a question in Teams. And of course, I'd be happy to answer any questions that you have when I see you in class tomorrow. All right, folks, hope you're staying cool. As always, thank you for the gift of your time. Take good care of yourselves until we meet face to face once more.